Yeah, I want to thank you for your invitation. I'm quite happy to be able to share with you some of the results we have been getting on our studies on the impact of Vespa velutina in several dimensions of the apiculture and environment impacts. So let's hope that you find it interesting. I'm going to start by introducing a little bit the Atlantic Positive project, which is a European Union funded project where several institutions from different countries have collaborated and doing some joint research on this topic. So just as a quick introduction, I know all of you are aware that Vespa velutina came from Asia, probably around 2003 to France, and it also jumped into the South Korea at nearly the same time. And since then, it has been causing problems in Europe all around where it has established. So here's sketch of how Vespa velutina has spread since 2003, and you see that the spread is very quick, and it didn't stop anywhere, but in the physical barriers that it found, the geographical barriers, and probably the weather is also a limiting factor. So we are also studying that in this European project. What I want to express with this graph is not only the rapid spread, but also the high density of occupation of the areas once it sets in. So I have done a rough recollection of how the invasive process is, and you can see, for example, here that it started in around this region in France and in 2003, and then it is spread by progressing of the invasion front through France at a speed rate of around 40-50 kilometers per year, until in 2010, so this is 7 years after it was first found in France, it crossed the Pyrenees and was first found in the Iberian Peninsula. What is interesting is that the following year, it was already found in the Minho region between Galicia and Portugal. So we can see here that very quickly it experienced two strategies for expansion. One is the front line expansion, which is slow and predictable, but we also have this kind of very long range. This is around 600 kilometers jumps. Probably they are mediated by human activity, so it's us who transport them across Europe. But that's just a theory. And then the next year, it was found in the north of Galicia, and also it crossed through other ways, through the other side of the Pyrenees into Catalonia. So this was around 2012. And then from these focuses, from these starting points, it started spreading. And in just a few years, 4 or 5 years, it colonized the whole of Galicia and started going through the north coast. And it met the other invasive front from the west, from the east, and both met in Asturias around 2014, and then it was also spreading south across Portugal. As you can see, the interior of the peninsula has been not invaded so quickly, and this is probably because low winter temperatures are a strong barrier for its settlement, because most individuals die during winter if they are very cold, if they are below zero temperatures. So this is probably a nice climatic limit for its spread. But it doesn't mean that global warming is not going to allow the species to progress in these directions. And it may take more time for them to set there, but they are likely to be able to adapt and to invade these regions as well. So we also detected through the genetic analysis another subsequent incomes from France into the West Iberian Peninsula region, and this allowed to recover the genetic diversity of these populations that were initiated by just one propagule a few years earlier. So what we see is that we have an expansion of the invasion front of the population, and then we also have inputs from the main region who help, and these inputs help maximize the genetic diversity of the invasive population. So actually, the genetic loss from the peripheral regions with respect to the central region is minimized. This is interesting because it is like a method or a property that allows the species to be more resilient to genetic impoverishment. And then a few years later, we started to have many more reports of long-distance jumps, even to Scotland. Well, you have already talked about those in England. There were also sightings in Ireland, in South Lisbon, and last year there was already a colony was detected in Cádiz, nearby the south of the Mediterranean Iberian Peninsula. So what we see is that actually slowly but steadily the population is expanding. Unfortunately for you, you are in an island. That's a big barrier for Velutina to progress. But as you know, you are aware of, you are a subject of an input from the continent, and I cannot stress the value of all the effort you are actually investing to prevent its settlement and spread in England, because actually the troubles that it causes are very very high, and once it's settled, it's very difficult to eradicate. This is just for you to know or to remember that there are many other events of wasps and vespids being invasive in other regions of the world. Most of these came from Europe and were transported to different continents, and none of these cases the populations were eradicated, despite huge efforts to do so. So once the wasps and hornets settle somewhere, it may be very difficult actually to eradicate them. And these are two other Vespa species which are not natural to the Iberian Peninsula, but are arriving here as well. This is the Vespa orientalis, which is native of the Levant, the East Mediterranean coast, and it has been spreading westwards, and the first colonies have already been found in the Mediterranean coast of the Iberian Peninsula. And this is Vespa bicolor, which is also an Asian origin or a native hornet that has been found in the south of Spain. So we are having a continuous input of new invasive species, and we don't expect this to be as dangerous or as harmful as Vespa velutina, but one can never predict which is the effect of an invasive species once it settles in a new environment, because it can behave differently from the typical behavior in their own region. Well, most of you already know the anatomical and morphological characteristics of Vespa velutina. This is the typical female worker, and you can see, well, when you see them flying, the first impression you get is you see a large hornet, mostly black, with some very tiny yellow marks on the abdomen, and you see a yellow halo around it. It's like a halo around the wasp, and that's the best way to recognize it. If you don't see it, you cannot handle it, or it's not stopped somewhere. So if you see it flying, actually you see this large black hornet with a yellow halo around it. And when you compare with other native species of Hymenoptera, what you see is very similar to the Vespa crabro, but the Vespa crabro is more yellowish, more orange, or even reddish, and it doesn't have these yellow tips of the legs, so it's easier to recognize. I just heard that you had a question about the sound that they make. Well, they are much quieter than the European hornet. The hornets make a higher sound when they fly, and the Vespa velutina is a bit lower. You can learn to recognize it. They're very easy to tell one from the other, and the Vespa velutina is quieter than Vespa crabro. Well, as you see, we have many inputs of invasive species, exotic species in Europe. They are listed more than 14,000 exotic species. 2,100 of them are invasive, so they can be a problem if they propagate out of control, and 66 of them have been listed as of European concern, and one of them is Vespa velutina, because it has a very strong consequences on the places where it inhabits. Regarding the ecology, we can summarize roughly into two main problems. One is the predation that it exerts on the native entomofauna, so we don't know which are the ecological consequences of this strong activity, and also specifically the pressure on pollinators, which can be derived from predation or just by causing them stress and changes of their natural behavior. In terms of the society, well, it's very alarming when the Vespa velutina arrives. In the media in Galicia, we used to have a very alarming news about an assassin wasp and everything, and people was very worried about it. And it took a few years for things to calm down. But people was very alarmed and worried about this new species. So in terms of human health, it has strong consequences. So in Galicia, there are recorded or attributed to Vespa velutina between 12 and 15 deaths. Sometimes it's difficult to know if these people have died directly by Vespa velutina attack or just other Vespa, or an allergic reaction to other wasps. So, but that's the best we can do. So this is what the numbers tell, and sometimes it's difficult to know which was the actual insect that had caused the death of the person. And there are around between 250 and 300 emergency admissions at hospital per year in Galicia, and these are the demand for vaccinations against allergic reactions for wasp bites duplicated. So in the area of Vigo, for example, they are vaccinating over 400 people per month against allergic reactions. So people is worried that contact with Vespa velutina can cause them harm. Then also, it obviously, people who work outside in the country are exposed to Vespa velutina attacks, and they're usually threatened by them, and they have to stop working or to change their routines. And this is people who do work outside, cleaning the forests and fields, and people who work with logging and garden weeding. Even the fruit harvesting is very much affected by the presence of Vespa velutina. So I do some wine at home, and last year it was impossible to harvest the grapes because all the vineyard was full of Vespa velutinas, and we had to change all the timing and strategy to do the job. Last year was much easier to do it. So the density of Vespa velutina changes a lot, very much across years and geographical regions. And then all of these impacts have a strong effect on the economy, and Anna is going to talk to you about these estimates a little bit later. So here you see how this is a Vespa velutina hawking over a field of mint. We call this mint. And as you can see, they fly around the pollinators, and sometimes they change their behavior just because of they are pressed by the Vespa velutina presence. So actually, Sandra Rojas in the University of Vigo has estimated and quantified this effect of the hawking effect of Vespa velutina on the pollination of insects. And here is a Vespa velutina hawking in front of a beehive, and you can see how they are very good at catching them, and even attacking them when they are on the flying board. And this activity of just one Vespa velutina can very seriously change the behavior of the bee colony. You see here a Vespa velutina. This one here is carrying. It went away. So I think I cut the video too early. So this one was carrying a pellet made of a honeybee. After it catches them, here you can see another one hawking in front of a hive, but this video is very impressive. You see the huge amount of Vespa velutinas that actually attacking these beehives, and how all the honeybees have stopped, and they just make this carpet, defensive carpet, but they end up getting into the hive and just trying to prevent the Vespa velutinas to come in. So all this pressure changes completely the dynamics of the honeybees, and we are interested in investigating which consequences does this have on the honeybee health and survivorship. Once Vespa velutina catches a bee, it cuts the head off and the abdomen and the wings, and uses the thorax to make a pellet. Also, here is the pellet. So you can see here how this Vespa velutina is coming in with a pellet made of an insect that it caught previously. So with this pellet, they feed the larvae inside the nest. So the European honeybees have very few strategies for defending themselves. One is this defensive carpet, which only prevents velutina from getting into the nests, into the hives, but they don't prevent velutina from hunting incoming and outcoming honeybees. So they actually stop flying around, and they just do this structure, and they end up hiding within the hive after a few days. And a second strategy is to try to capture and kill the attacker, but European honeybees are not very efficient. I recorded this in one of my hives. So you can see here a ball that was made of workers who probably captured one Vespa velutina hornet. And they make a ball around it and try to asphyxiate it and heat up, increase the temperature inside, so the hornet actually dies. But some studies have demonstrated that European honeybees are not very efficient with this, and they very seldom catch one hornet, and they are very inefficient in killing them. So actually this is just a kind of a atavic behavior, and is not efficient against the Vespa velutina. It is probably efficient against other invaders in their hives, but Vespa velutina doesn't. Vespa velutina attacks are not prevented with this behavior. So the arrival of Vespa velutina to Galicia had some serious consequences, and people started using all kinds of control methods to eliminate them or to control them. So these are the traps with some liquid attractants. These are another version of the how do you call them? Trojans. In this case, they cut the back legs of the hornet, so they cannot clean themselves up, and then they spread some insecticide on them and free them to fly to the nests. This is commonly used by beekeepers. People get so desperate that even do hunting seasons for destroying honey nests, which is not very efficient at all, because probably they are able to build new nests somewhere nearby. And these are people who even used gas attacks and against the Vespa velutina, and one family actually destroyed their walls because they tried to gas out one of the nests inside a wall, and exploded, and it just destroyed their wall. These were previous methods to try to protect the hives, which are completely inefficient, because you cannot put all the hives within one of these structures. And this is one of the methods to keep velutinas away of the entrance of the hives. You had a nice talk about these methods earlier, so I'm not going to get into the details. This is just to demonstrate that people, once velutina sets somewhere, people get very, very nervous, and they use all kinds of strategies to try to avoid their presence in their apiaries, which is sometimes is not the wisest thing to do, and it's better to go into and to use the other methods that have already been tested. One of these methods is this is an electric hub, which you have already heard about it earlier as well, and is proven very efficient in terms of it's more specific, so it mostly captures the Vespa velutina, but is more expensive and harder to keep working in front of the hives. And sometimes things even get ballistic here, because they use a rifle to shoot insecticide balls into the nests that cannot be reached by the people who usually destroy them. So this is another method commonly used in Galicia. But again, this is not very recommended, because if all those balls that you miss, or all those missed shots, are actually going to spread the insecticide around the countryside everywhere. So I think poisons and these kind of methods have to be controlled and regulated, so they are not a threat to the environment. You have also been talking about the prevention. You are in this situation in Britain, and this is very good for you. And I should stress, I cannot stress enough the usefulness of all the methods you put forward to keep in this situation and avoid the setting of the invasive population in your islands, because once it gets there, you have a very short window of time to try to eradicate it. And if you don't eradicate it, then you get into trouble with expanding, exponentially growing population that is going to be very difficult to deal with. As I have already mentioned before, most wasps were not ever eradicated from the places where they were taken from Europe, and once they set there, you have to deal with containment and long-term management, but this is much more expensive and time-consuming, and is much more of a threat to the environment and to the people and apiculture. And given that we were in these different parts of Europe were at different stages with regard to velutina. So Britain was in the prevention stage, but other regions were receiving new inputs of Vespa velutinas, and some other regions were already in this area of long-term management. We decided to propose and combine our efforts into trying to in this initiative, which is an Atlantic positive, and our main goal here was to contribute to the preservation of the pollination services through the development of integrated approaches for the control of Vespa velutina that could be interesting for different European regions in different stages of invasion. So this project started in May 2019, and due to the COVID restrictions, it has been delayed for 1 year. So we are expecting to finish it around spring in 2023. So there are different institutions that are partners in this program, and we are representing the different Atlantic regions that were directly affected by Vespa velutina. So we have people from France, from the INRA and the University of La Rochelle. We have people from NACER in the Basque Country. We have 2 universities from Galicia, and another 2 institutions from Portugal, which are the INIAF and the Universidad de Trás-os-Montes. And there's also people from England, from the University of Exeter, and Peter is going to talk later, and also people from Ireland who are interested in preventing Vespa velutina to reach your countries and to get established there. There are also over 20 other associate participants, including representatives of the central administration in Spain and in France and in Portugal. And we also have local communities and councils who joined this initiative and collaborate with the research and produce that and help the investigations. We have representatives of many beekeeper associations of all these regions, and also some specific research centers, for example, from the Guadalajara, who are specialists on the analysis of pathogens, of honeybee pathogens, and also the Polytechnic Institute of Braganza. The main objective of this project was to prevent the expansion of Vespa velutina and to minimize the impact of where it has already established, its impact on ecosystems and also on the socioeconomic development of these regions. So the means to achieve this objective are to develop and improve detection and capture techniques, to improve the management of the beehives, to reduce the impact of the plague, and also to define an appropriate and environmentally responsible control methods. So these are the main lines of research, and we have different fields of work. So some people is working specifically on the Vespa velutina biological cycle and behavior. And so these are some of the initiatives in this area. So like study the pollination, its impact on pollination services and its dietary habits. They are studying, for example, the diet of larvae, of velutina larvae. And we also have people studying how the honeybee develops different defense strategies. And we also some other people search on radio tracking methods to find their nests. This is Peter and Sandra's work on this topic, and Peter is going to talk to you about this later. Also, there are people interested in studying how to monitor the expansion of Vespa velutina. So there have been doing some um, analysis of methods to try to identify the population by aerial photography and the use of drones for nest detection and destruction. And also there has been an initiative for the dynamic modeling of the Vespa velutina distribution, where we produced a prediction of which regions of Europe are likely to be invaded by Vespa velutina, and which regions could host a sustainable population of Vespa velutina, as compared or taking as a reference the original distribution region in Southeast Asia of this species. And then we also have been working on improving the techniques to minimize the impact of on honeybees and other pollinators. So we are studying the effectiveness and impact of traps and baits in the indigenous fauna. We are also studying the interactions between velutina and the native entomofauna. And we're trying to figure out which are the best management strategies to minimize the impact of Vespa velutina in bee production. And this involves capture methods and protection of the beehives. Then in the other line of research, we also have been trying to develop a strategic plan to protect the ecosystem and the economic activities. So Anna, who is going to describe you later, has done a socio-economic analysis of the plague. We have developed several educational campaigns on different sectors to try to communicate the results of our work, and a strategic plan has been written in order to organize the strategies and how to do when you find or how to avoid the negative effects of Vespa velutina. So these are most of the research lines. And finally, people from Ireland and the UK have been working also on studying the routes of spreading of the maritime spreading of Vespa velutina, to try to avoid and to prevent the input of new specimens that are arriving to England mostly, but sometimes even also to Ireland every year. So these are more, in general terms, the 5 main research topics that have been developed in this program. And here is the webpage of the project, and here you can find all the information that we have been producing, and it will be updated until the project is finished. So you have all these topics where to search for information. One of the most efficient protections for the honeybees are the electric harps, as you have already been told, and these are represented here. So I'm not going to get into details, but the benefits of these methods are that they are very efficient from capturing hornets. They are much more specific than the liquid bait traps, and with they can protect a reasonable number of colonies from the main effects of the honeybee of the hornet attacks. This is why we wanted to check what effect do they have on the welfare and health of honeybee colonies. So to do this, we, in a strong collaboration with Sandra from the University of Vigo, actually she was the responsible for this study, we set 3 experimental apiaries with a group of colonies that were protected by harps, we put one harp by colony because we wanted to make sure that there were differences between the protected colonies with another set of colonies in each apiary which were not protected. So we wanted to understand which effect do the protection of the colonies have on their behavior, welfare, and health. To do this, we analyzed in a 2-year period different parameters of the colonies, which allowed us to describe the harvesting activity, the food reserves, the brood quantity, and worker weight, and also the parasitization patterns. So I'm going to talk to you mostly about this last topic because it is the one that we have been working on more directly. This study was started in July 2020, and we took samples from July, which is the beginning of the strong attack period of Vespa velutina on the honeybee colonies, and after the attacks in 2020 and 2021. For the parasite analysis, we focused on enteropathogens and also in Varroa. For enteropathogens, we analyzed the Nosimatidae, which are known to have strong harmful effects on the honeybee. And also we analyzed Trypanosomatidae, Lotmaria passin and Ctidia bombi, and Ctidia, well, all kinds of species of Trypanosomatidae, more than 6 species, and also Lipotrophidae, which are known to grow on the fat tissue of the honeybees. So when we analyze Varroa, for example, we got these results in our study of infestation. So we started the experiment with very low infestation of Varroa in the colonies, and the infestation increased a lot at the end of the summer, early October in 20, and the same pattern was found in the next year. We have to point out that there was an anti-Varroa treatment here with amitraz, so it's because that's compulsory, and it represents a regular hive management. And what we see is that the protection of harps against Varroa against hornets doesn't have any significant effect on the Varroa infestation. So we don't see any difference on the number of Varroas found per 300 bees on the colonies protected versus the unprotected. There are no differences. We only see a strong seasonal variation, but no differences with regarding to the protection effect of the harps. We did find that an association between Varroa infestation and drone brood, but the problem was that, or the situation was that most drone brood was actually in the protected hives. So actually, we did, in the end result is that we did not see an effect of protection, direct effect of protection on the Varroa infestation. And regarding the other parasites, we did find strong differences between the protected colonies and those that were unprotected. So first, we detected a strong seasonal variation, as you can see here. And there is a huge increase of prevalence of Nosimatidae and Trypanosomatidae in the protected colonies. So the protected colonies show a pattern that is more similar to the patterns that were previously described in colonies that were not attacked by Vespa velutina. So, like here in this article. So, what we see here is that the Vespa velutina attack has a strong effect on the prevalence of parasites, on the dynamics of parasites between the honeybees, And when we, the effect actually is that the colonies, the honeybee colonies that are paralyzed and stop harvesting food show lower infestation in at this time of the year, which is in the late spring or early summer of 2021, and then the differences disappear by late summer. So this is interesting because actually what we find, as I'll explain you later, what we find is that the protected colonies do have a much better performance than the unprotected ones. So it seems that what we got with this analysis is that electric harps protect the bee colonies by reducing the predatory pressure and attenuating the colony paralysis. So this colony paralysis prevents the honeybees from working outside of the hives, and this change in behavior changes the normal patterns of the honeybee and parasite prevalences, actually reducing the prevalence. We also saw that the unprotected colonies do not display a higher parasite prevalence, and we also detected that the protected colonies presented greater activity, greater pollen and nectar collection, larger amounts of brood, higher weight of the workers, and higher overwinter survival. Particularly, these differences were more obvious in the apiaries that were under a stronger attack. So we see that the presence of the harps helps the honeybees to keep their regular behavior, and this translates into a much better health inside the colony. And surprisingly, the prevalence of parasites is lower in the colonies that are not protected. But this doesn't have a positive effect on the colonies. On the contrary, the colonies that are not protected have a lower survival rate over winter, which means that the effect of the parasitization on the colonies is probably complex, and it has to be understood in the light of interactions with the other parameters inside the colony. So probably weaker honeybees are more sensitive to the presence of parasites than the stronger and better fed honeybees. So the winter survival is worse for the weaker honeybees, which are those in the unprotected colonies. We were also interested in analyzing the effect or the impact of the Vespa velutina presence, not only in the honeybees, but also in the other pollinators, in European native pollinators. Because as a part of our studies, we came to the conclusion that the Vespa velutina can reach huge densities in some regions, at least in Galicia, but probably in most parts of Europe. And so we estimated that there can be over 100,000 specimens of Vespa velutina per square kilometer in Galicia. So with these huge densities, Vespa velutina is probably interacting with the native parasites of the native Hymenoptera, and this interaction can have unpredictable consequences on the host and parasite dynamics. So we proposed two theories with regard to this. And the first hypothesis is that the Vespa velutina's reproductive success in Europe probably reflects a lower parasitization level than the European native Hymenoptera. So this is kind of an adaptation of the enemy liberation theory, which states that invasive species sometimes carry a lower load of parasites and are affected by fewer parasites than in the original geographical regions. So they actually compete in better terms against the local fauna. And this can explain the success of some invasive species. The second hypothesis we wanted to test is that Velutina actually interacts with most parasites that are present in the regions where it's invasive. And this could change the parasite host equilibrium. So to do this, we got samples from Vespa velutina and local and native Hymenoptera from regions representing the distribution of Vespa velutina in Europe. So we got samples from Jersey, and we have to thank Alistair for sharing these samples with us. We got samples from France, from the Basque Country, from our region, Galicia, and also from Portugal. And we got samples of Vespa velutina, and also, when possible, we got samples of common Hymenoptera native to Europe. So common wasps, paper wasps, native hornets, and bumblebees. And we studied the patterns of parasite diversity and prevalence across hosts and across regions. Again, we focused on the enteroparasites of the groups Nosematidae, Trypanosomatidae, and Lipotrophidae. To do this, we use molecular tools to detect the parasites, and we use different sequencing methods to analyze and determine the sequence identity of the parasites. We got over 1 million sequences from this analysis, and we got some interesting results. For example, we detected a strong geographic variation of the parasite prevalences across the different hosts. So, for example, in Galicia, we got the highest prevalences of any parasite, as you can see. And in Jersey, we got the lowest prevalences for this parasite we have been studying. So the parasites that affect Hymenoptera are vary locally very strongly in prevalence. We also found that there is also huge variation across parasites. For example, Nosematidae are the less common, and most samples are very rich on Trypanosomatidae and Lipotrophidae. So we have a variation across types of parasites and also across geographic regions. We also found that Vespa velutina shows lower parasite prevalence in general than the other local Hymenoptera. So this result suggests that, in effect, Vespa velutina is exposed to the fewer parasites and with less prevalence than the native Hymenoptera, which is nearly 25% greater. Perhaps this can help explain the huge reproductive success of Vespa velutina in Europe. And this graph is just to show you that we got some other interesting information. For example, these are a group of parasites. Each circle represents a different parasite, which is connected to other of the same species. All of these come from the same species. So this is genetic variation of one type of parasite. And you can see here that the parasite in Vespa velutina of this species are more closely related to each other than to the parasites which are more common in the native Hymenoptera. So it looks like there is a different genetic differentiation between the parasites that we are finding preferentially within the Vespa velutina from those we find in other native Hymenoptera, and we have to explore why this is so and which consequences this might have. Another result we got in this study is that, and they represent very well the fact that Vespa velutina, which is here coded in gray, appears in, so all parasites that you see in this tree. This tree represents the genetic variation of parasites of trypanosomatids, and each of these clusters represent a species, one of these species. So these are Lotmaria passim, these are Critidia cantocephali, these are Critidia mellificae, this is Critidia bombi, and you can see that Vespa velutina is exposed to most parasite species. So actually, what this is telling us is that Vespa velutina is interacting with all the native parasites. At the same time, we also see that some parasites are present in most hosts. So this is interesting because it's telling us that the parasite populations are actually interacting with very different hosts, and they probably transmit from one host to another through the flowers and other feeding points of the insects. And actually, there is communication and sharing of parasites between different hosts. And although in some cases, for example, here we can see that most Critidia bombi were found in bumblebees, which is their main host species. But still, this is very interesting because what it's telling us is that any Hymenopteran parasite can find its way to all the species, to most Hymenopteran species. So one has to be very careful when managing parasites to prevent the arrival of new species that can be harmful to one or to most Hymenoptera. And the last result that we got, which is also very interesting, is that this depth of analysis allowed us to identify new clusters of sequences that probably represent new parasites. So they surely need to be studied in order to determine which effect they have on the health of the honeybees, but also in the other Hymenoptera. So this is what we are trying to do, and we are, with this kind of essay, we are trying to develop methods to maintain hornets, Vespa velutina, in the lab and to expose them to different parasites in order to test their ability to infect them and to evaluate the pathogenic properties of the parasites. So as a summary of these results, of this analysis, we got a huge DNA bank of over 1,100 Hymenopterans from across Europe and Asia. We got over nearly 1.5 million sequences of parasites. We found that Vespa velutina interacts with most common European parasites of the native Hymenoptera. We found a large variation of parasite prevalence across European regions, and we also found a huge prevalence variation across the hosts, which is interesting. And finally, we got a new parasite taxa, which probably are interesting to understand the relation between parasitization and the health of the honeybees, but also of the other European pollinators. And this is the group in the University of Santiago who have been conducting these studies. And we also want to mention our collaborators and contributors with samples and idea and with work. who are the University of Vigo, Instituto Politécnico de Bragança, or INIAF de Portugal, NACER from the Basque Country, CIAPA, IRIAF from Guadalajara, and INRA from France, and the government of Jersey. And the funding from this analysis was partly produced by European Union and other part from the local administration. And that's all about what I wanted to say.
Well, thank you very much, Giulio. That was a massive amount of work that you've covered there, and it just shows us what the research is that is going on. And we're very grateful to all those researchers, to those you've mentioned, and to the others around. They're doing such huge amounts of very arduous work to actually try and solve this incursion of these Asian hornets. I've got a couple of questions for you. The first one is, it's relating to what you were saying about the protected hives and the unprotected hives when you were looking at the effect on the bees. Could this mean hornets may be picking off the parasitic? Oh, it might have just gone from my screen, but basically it said the parasitical. Sorry, could the hornets that are being affected by the parasites be being picked off by the, are they being picked off the, sorry, I'm going to start that again, I've made a total hash of that. Are the bees, which are being affected by the parasites, being easier for the hornets to pick off, and therefore sort of affecting the unprotected colonies? And although those are going down in number, is it because the parasites are actually increasing? I think that's the nub of the question that was asked.
Yeah, well, it's difficult to understand the direct relationship between the hornets and the honeybee parasites. What we see here is that a hornet attack paralyzes the colonies, and this completely changes the interactions, the natural interactions between the honeybees and the parasites. And the change in the interaction is probably due to the lack of external activity of the honeybees. So the honeybees stop harvesting, and this lowers their exposure to the parasite species. But this doesn't necessarily mean that they are healthier. What means is just that the relationship with the parasite population is not normal. And then what we see at the end of the study is that the protected colonies do much better than the unprotected ones. So the fact that the parasitization levels are lower in the protected colonies doesn't necessarily mean that they are healthier. It probably means that the paralyzed colonies are weaker and they can stand in, they are more affected by, or they are more sensitive, or they are less able to withstand the parasitic presence. So they are weaker they're weaker, and despite having fewer or lower parasitization prevalences, they die off at the end of the year more often than the protected colonies. So there is not a direct relationship between parasitization levels, but probably we have to understand it through interaction with other parameters of the health status of the colonies, which are worse in the unprotected hives.
Thank you. One other question: in apiaries where hive entrances are in different directions, where would you place the heart? Because in UK here, we do tend to alter the direction of our hives so that the bees coming back don't get so confused. So if you alter those, where would you put the harp to be most effective?
Yeah, we don't usually put the harps before the how do you call it, when the honeybees I can't remember how you call it, when the honeybees fly out.
Oh, so that they're a little bit further away when they fly out. Is that what you mean?
No, how do you call it when the new queens fly away?
Ah,
how do you call that?
yes, that might. Well, that's when they go out to mate.
Swarm.
Yeah, swarm.
Swarming. Is that what you're talking about?
Thank you.
Yeah.
The swarming. So we usually don't put the harps before swarming.
Right.
Because in those moments, actually, the honeybees can fall in the harps. We usually put the harps later in spring and early summer, and then there's no problem at all with the localization of the harps in front of the colonies. So not behind the colonies, but ahead of the colonies, as you see. And we can put in like just a few 20-30 centimeters separated from the hives, in front of the hives, but not in front of the entrances, but to the side of the hives, but not behind the hives, but in front of the hives. So because the hornets usually hunt in front of the hives, so when they fly through, they find the harps in that area. So in front of the colonies, in front of the hives. I have a picture here, so you can. I don't know if you can see it here.
You share your screen, we probably can. Yeah.
I'm going to try to share it.
While you're sharing it, I must admit I was quite horrified to see the numbers of hornets attacking the hives. Just incredible.
Yeah. So you see here is can you see the?
Yeah, protection of the hives.
Yeah, here. So here are the hives. These are the harps, and these are the hive entrances. So they are not in front literally, but they are just in parallel to the hives. These are the harps. So the flies, the honeybees fly in this direction, come out, and they learn to avoid the harps. And if they touch them, they seldom fall in the harps. So this is not a problem. But in the season where I forgot again the swarming season. So
yes, so you wouldn't.
In the swarming season, we don't put them there.
No. How quickly do the hornets? Do they ever learn not to go near the hive? The harps?
Yes, I put them like early July or late June, the harps, and I very seldom find any honeybee falling. And the hornets, I don't really think they learn how to avoid them. They usually avoid obstacles. So if they see them, they avoid flying through. But I don't think they are very good learners, and they learn how to avoid it. No, I don't think that's a big problem.
Well, it didn't look a problem with the ones I saw. There were thousands below the harp.
Yeah, I sometimes can get in just one harp. I can get between 300 and 500 hornets just per week.
I think we're going to have to stop here, but hopefully you'll be around at the end to answer any more questions. But if you can't be there, maybe we can email them to you and get a response. And okay, just to double check, you are happy for us to use your material on the BBK YouTube, are you?
Yeah.
That's very kind of you. It's very informative, wide-ranging talk, which I actually very informative. So thank you very much for your time, and thank you very much for the way in which you presented it so clearly. So thank you.
Thank you.